Season 3, Episode 3, Solar System Sanctuaries. And welcome back to another edition of the s3e3 podcast. I just caught Emily as she was just about to take a sip of her coffee, but she can't now.
Not allowed.
We've started. My name is Chris Stewart, and I am sitting, as ever, at the round table in the office of one Dr. Emily Brunston. Emily, how you doing?
Hello. I'm well, thank you.
Good, but we're not alone
No.
today. We're breaking with 130 episodes of tradition. I think maybe we've done a couple of guest episodes in the past, and this makes maybe number 3. Emily, who have we got? Who have you invited along today?
Well, I've invited my dear colleague, Clément Moissard, Dr Clément Moissard, who is joins me actually as a colleague on an astrobiology module that we co-teach together, because he is an expert in this aspect of astrobiology, but also is a space solar system physicist in his own right as well. So,
Clément, welcome to s3e3.
Well,
the
thank you.
podcast
Hello.
is very hard to spell. Tell us a little bit about yourself. Who are you? Who exactly are you?
yeah, was that a reasonable introduction, or did I just completely lie there?
Yeah, absolutely. Well, I mean, an expert might be a bit of a big word, but I'm a lecturer at the University of York, where I teach astrobiology with you and other wonderful colleague, Kelly. And my background is in space plasma physics. So I study the interaction of the solar wind with different planets or different moons. That's a new interest of mine as well. And yeah, that's what I do. That's me.
And that's really useful, because today we are going to be talking about stuff within our sort of, on an astronomical scale, our local backyard. This entire series, so Clément, bring you up to speed. We did about 120 episodes of this podcast, which we then decided, well, that's now series 1. And we went, series 2 will be 6 episodes. Okay. And we did that. What was series 2 about? That was about
Exo things.
That's right, exo things. Bunch of exo outside of our solar system, elsewhere across the galaxy. And then at the end of that one, we went, the one thing we haven't really tackled is exo life not here on Earth. And generally speaking, so far in this series 3, we have done stars. If you're going to have life in the universe, we probably need a star.
First you need stars.
So we began there, and then we said, okay, fine, given that we need a star, and the right kind of star, not really horrible stars that are going to blow up or destroy you with X-rays or whatever it is. You need a nice, friendly star. But then you also need something for the life to be on, i.e. a planet.
Yep.
So episode 2 was planets. But now we're getting to, all right, well, let's have a little bit of a think about where and the sorts of environments that we might find life. And we thought we'd have a little bit of a look in our local backyard.
Yeah.
So where are we going today with that question, Emily?
Well, I'm just going to kick us straight into the midst here, because I think it's quite obvious that at least the human endeavour has been strongly focused on one planet in our solar system so far, one that we've sent the most probes and robots and flying helicopter things as well, and that's, of course, Mars.
And you have a wonderful picture of it just behind you.
Oh, yeah. So there is water.
Mars on a stick.
With you see the snowy cap on the top? It's
perfect.
It's actually correct.
Yeah, this being an audio thing, we're now talking about something visual in the real world. So behind Emily on her wall, there is a picture of Mars, and that is from the solar system walk across this campus here at the University of York, which is very, very cool. And Emily, you were involved in setting that up?
I helped the students a little bit
to
set it up, but it was really the students who set it up.
What about that planet? I think I need to say, because it was so funny, we were teaching a seminar on what's called water on Mars, and that planet was, fake planet, was literally just next to the room, and it started raining. and I just stopped the workshop and was like, wait, it's raining on Mars.
It's literally. I mean, in the picture behind Emily, there is actual snow on the top of the red ball that represents Mars. Yeah. So if you're anywhere near the University of York, do come onto campus and check out the walking tour of the solar system. Yeah. But that's not what we're here to talk about today. No. We are, however, talking about Mars. Not that Mars, but the real Mars.
Indeed. Yeah, so let's kick off straight into the deep end with Clément. How habitable do you think Mars is?
Well, the surface is probably not very, very habitable. It's very, very dry. It's extremely cold. It is just not a place you want to be. Definitely not. Now, the thing about Mars is that there's a lot of water on just under the surface, a few centimeters below. And I mean, the evidence is just wonderful because we can see it. The thing that I really love is the picture we took from the Phoenix lander. Just went on Mars, scratched the surface, and there was ice. And
I'm not sure that I was aware of that. So we know it's there. We've seen it. We've found it. We've poked it. Mm-hmm. Wow. Okay.
Yeah. We haven't licked it yet and had our tongue stuck in.
Don't lick the Martian ice. That should be the title of this episode. Don't lick the Martian ice.
I was just reading about it recently, and there's something called percolate. I don't know much about chemistry, but that's not good for life. And it's the Martian water is full of it.
Okay.
So you don't want to lick it.
Right. Okay. But I mean, water's good.
Water's good.
You know, as life goes, certainly on this planet, we know water's good. And so water on Mars, that's not a negative thing.
Absolutely not.
It's a positive thing.
And also, life is very adaptable. So whatever chemistry might kill us humans might be very good for something else. Who knows?
Sure. But as far as we know so far, I'm looking at both of you with a raised eyebrow, we haven't found life on Mars yet, have we?
Not yet.
Despite what all the headlines seem to come out with about every 6 months or so is conclusive evidence surely screams the headline of the Daily Mail, you know. But we haven't found it.
Yeah, and that's been since the 1800s.
Right. So, but it kind of feels like every 6 months or so, like it feels like we have almost found it.
Yes.
So what have we found?
Okay, so I started with water. Of course, there's at least 3 things that we need for life. We need energy, water, and I'll simplify things a lot and I'll say carbon. And we definitely have all 3 on Mars. So we have the ice. It's pretty much everywhere. And we have the energy because on Mars there are volcanoes that are not active, but they're not extinct either. Clearly, we have signs that they are just dormant. The last eruption might be a few dozen or a few 100 million years ago, which is nothing on a... I was about to say geological. I don't think that's the right word for Mars.
Astronomical,
cosmic,
yeah.
Cosmic,
or
yes.
whatever. Marsological. And carbon is also there, and that we have a lot of rovers that keep picking things up and do just a bit of chemistry experiments. Say, oh, that's a complex carbon molecule. So we have the 3 ingredients. And recently what we found is liquid water on Mars.
Okay.
And
not just ice, but liquid.
Exactly. I mean, which is not really a surprise because you have a hot core, you've got ice on the surface. At some point, the two are going to touch somewhere and you're going to have liquids. So at least that would be my expectation. And we found it, I think it was last year, some radar experiment have said, oh, look, liquid water. It's quite deep under the surface, but it's definitely there.
Right. So I was just about to ask you that. So it's radar. So it's not like one of the rovers sort of stuck a finger in it, went, oh, it's wet. It's we know it's there because we've sent waves down into the ground and they've bounced back and we've gone, there's liquid water under there.
Yep.
Okay. All right.
You know more about this sort of thing than I do. Is it radar? Is it seismic waves? I'm not too sure.
I think they've done both, and I think that it's more like there's a underwater cave with a lake in it or something like that. So it's all a bit kind of mysterious.
Very cool.
Yeah.
Very cool.
All right. So we've got all of that.
Yeah.
So Mars is looking good then.
Well, I mean, let's ask Clément how much more evidence do we need to get from there to life?
Oh, I don't know. I'm a very basic guy. I think if I see it crawl around, I'll believe it.
So, if it leaps on your face, then you know that it's life.
So get me a camera in that lake. Show me something that moves.
Show me a Martian squid, and we're there. Yeah. But I mean, that like I do remember at least once, maybe a couple of times over the. You know, I mean, I'm old now, right? So I've gone through this cycle a few times now. I'm sure there have been times where, oh my goodness, one of the rovers has found a rock and it's got squiggly things in it when you look at it under a microscope that look like that's probably like ancient remains of life. And it feels like that has come and gone a number of times, that we've eyeballed things and gone, I reckon that's probably what life left behind a long time ago. And then things have gone very quiet. So we haven't even found that much yet. Am I right?
Well, we found a few things that are tempting to attribute to past life, but it's very difficult to even define what life is. So long dead life is even more difficult.
Sure.
Which, again, I go back to my basic definition. If it moves, that helps.
Controversial. That thing's crawling towards me and it looks mean. Yeah, that's
We're not
like,
pretending to be the biologists.
Exactly.
Let's just make that very, very clear. There's a very large asterisk on this episode. We are not the experts in that particular field. But I mean, I like your definition. If it's walking towards me, if it's swimming towards me through the underground Martian lake, then I think we're good. But otherwise, it's really hard to tell whether or not squiggly lines in a rock are. There's all sorts of things that can make squiggly lines in a rock.
Very difficult.
That could have been ancient bacteria or it could have been something else. Who knows?
Absolutely.
So in your best guess, Clément, do you reckon we're going to find, if we find life on Mars, are we going to find life that's living right now? Or do you reckon it's just going to be some kind of like fossil, a hoof print? I don't know.
Well, the thing is, the evidence is going to be way more compelling if it is still alive, right? So is it going to be the first thing we find because it's more present or more likely to be present? Absolutely not. It's maybe the first thing we find because we can definitely say, oh yeah, that's alive.
Right.
In a way that is much harder to do with a fossil that may just look like a weird rock chemical geological process that happened a long time ago, and making the difference between the two, past life or past something, is exactly what people are struggling with at the moment with the latest discoveries we've had on Mars. So I think both are possible. If it's still alive, it's easier to tell.
Sure. So your best guess then, if you were to put 50 quid on the table right now, do you reckon Mars, we are going to find life that would happily draw a line under that one, we've found it? Do you reckon it's going to happen?
Yeah, 51%.
Yeah. That's worth putting money on. But I mean, that's a good claim. Like, I've met enough people, in my life who have gone, absolutely no, not going to happen, not a chance. And like, I'm sure they're actually hiding behind the rover right now, just following it around. But it's such a tantalizing question because it's the next one. It's the next planet out. Like, currently we have an N of 1. We've talked about this before. We have an N of 1, and that's us. N of 2 being Mars. Like, that's either hell of a coincidence or life's everywhere.
Absolutely.
Right? So Mars would be awesome. And you're prepared to say, yeah, look, 51%. I'm not saying it's certain, but I'd put a little bit of money on the table. Could happen. Yeah. Awesome.
Interesting. And then I guess I'm following that up. Do you reckon that we might find life that we accidentally took to Mars?
That would be the worst scenario to me. Because I think my understanding of why it's so exciting to find life is because we want to know where we come from. And if we find life that we brought there, it doesn't tell us anything. It just means, life can survive in extreme environments, which we already know from all the weird places in which life thrives on Earth. But then here's the thing. You can imagine two scenarios where you find life that has no common ancestor to humanity. And that's just plain fascinating, because if you find that, you can say, okay, as you say, life must be everywhere or it's hell of a coincidence. If you find something that has a common ancestor from humanity or, whatever, life on Earth, it's a really interesting question too, because then you ask yourself, okay, but when did it come to Earth or to Mars? And if it's 2 weeks ago on the muddy boots of an astronaut, it's such a boring prospect. But if it's, 4 billion years ago because it was brought in from elsewhere, or if it's because of matter exchange between the two planets, meteorites flying around, that sort of thing, then it becomes fascinating. I mean, for all we know, we might be the Martians trying to go home.
Yeah. Isn't there a word for that?
Panspermia.
Panspermia. Yeah. Where we have, like, Earth was seeded by something from something else, which just kicks that can further down the road. But as you say, if you were to find evidence of something common between Mars and Earth, like, that's a huge question, because it's not like we're talking about it as if it's next door. It's a long way away, right? And it would take a hell of a lot to get anything from Mars, unless it came on the bottom of an astronaut's boot.
Exactly.
So that would be a fascinating question indeed.
But it does happen quite often, actually. Well, quite often. I mean,
What,
probably-
between Mars and Earth?
Yeah, just rocks. You get a massive impact on one of the planets, and one of the debris just fly to the other planet. Some of the most interesting evidence of things that look like life, like the squiggly worm you talked about, are from Martian meteorites that we found on Earth.
Right.
That came this way, just randomly. So that could be a way that life has moved from one planet to the other.
Yeah. Well, I guess if Mars is kind of a 51%. I mean, we just went with the obvious. What about the other 49?
Are we going down from here?
Well,
I think
that's actually my question. Do you
Yeah.
think other places in the solar system are either better or worse prospects?
Oh, that's a good point,
That's a
actually.
good
Is Mars our best one? Or actually, are we looking past already the most obvious one, which is X? What do you think?
I think I need to specify my 51%, by the way. The 51% I mean is if we find something that we are convinced is life, my best guess is it's going to still be alive.
Okay.
Oh, okay.
Now,
Yep.
if the question is, will we find something on Mars? I'm like, 98%. We just haven't,
Right.
we're not there yet, but we will. I'm
Okay.
almost certain of that.
So just to be clear, from your point of view, you think it's pretty certain. Let's round that 98 up to 100.
Yeah.
Closest 100,
Oh,
right? You're certain that Mars has had life.
Yeah.
Whether it still does or not is another matter, but it has.
Yeah.
Wow. Okay. That's a big call.
And the question is, how interesting is it? Is it different ancestor, common ancestor? What do we do with that answer? Did we bring it in there ourselves?
Yeah, did we just not clean one of the rovers particularly well?
So before we move off into other parts of the solar system then, can I just probe that a little bit then? So what makes you that certain? What do you sort of come to that with to say, clearly, obviously, Mars has had and parenthetically may still have life?
I think I'm saying this because the evidence that it exists on Earth pretty much everywhere you look is so strong. And then I just do not see why it wouldn't be on Mars. And we have also fossil evidence that on Earth it arose as soon as it could.
Right. Okay. So it's sort of coming from the life finds a way philosophy.
Yeah.
You know, as you say, we've seen it everywhere on Earth. Do we have a sense of on Earth? I mean, God, I wish we had some biologists with us. Whether life arose multiple times or it just happened once? Because, I mean, to me, there is an interesting question in there, which is incredibly unlikely random thing happened on Earth, therefore life just proliferates everywhere and gets really, really good at Earth. But ain't no way that's happening anywhere else. Yeah. Versus it just happens all the time. And so, of course, it's going to be on Mars.
Yeah.
And I don't know whether or not we have an answer to that one.
I think most astrobiologists are quite set on the fact that the second answer is the most likely. It's almost the Copernican principle. Like, we're not special. Why should we be special? And to some extent, that's a philosophical stance, but it's been
Here into the philosophers.
It's been very productive.
Yeah.
So I think I'll just stick to that one. Yeah. And then we need to ask a biologist.
Yeah.
Because here's the question, right? We keep saying n equals 1, but is that true? Because maybe on Earth we actually have n equals 3,000 already.
Yeah, that's a good point. Is how many of these experiments have we had on Earth? You know, you can think of it as, well, just one. And so we need to find somewhere else in order to get to. But it could be that there have actually been loads here on Earth. It's happened many, many times. We don't know. Know. If only we knew some biologists.
Oh, well.
Should see what we can do about that.
Let me just go for
In a cupboard somewhere.
Yeah.
All right. So we were, before that little tangent, we were about to then leave Mars and head off into potentially other
clearly
parts
we've
of the
just
solar
sorted
system.
out Mars, so
I think
this is great.
So Mars, tick.
Yeah,
I
excellent.
mean, it's just a matter now of finding it because we know it's there. Okay, so elsewhere in the solar system. Is there an even better bet than Mars, I guess is the question.
Yeah, well, I guess the next best place that you'd typically find, at least in a textbook, would be your icy moons of a couple of the giant planets. So we've got Europa, Enceladus. Do we want to start probing into those, Clément? What do you think?
Titan,
yeah,
all of that.
So as a non-astronomer and non-space type person here who just asks questions, why are those the next best bet then? I mean, we've gone from planet, which is to all intents and purposes quite earthy, to now we're going to look at moons around enormous gas giant things. That feels like a big jump to me. So why are we now looking at those? Why are they good?
Well, we're going back to the three ingredients I was looking for earlier, which are energy, water, and carbon. And then you look at the solar system and you find that it's everywhere.
Right.
Especially the moons around the gas giants. So water is actually not very surprising because water forms pretty far away from the stars in general. Actually, the surprise is that there's so much water on Earth. Not that there is a lot of water next to gas giants, because that's just where water is formed. Now, in terms of carbon, it's kind of the same thing. It's everywhere. It's not a rare molecule, so it's just there. And we can measure it through spectroscopy, for example, and we know it's there. So the really interesting thing is energy. How is it possible that there is so much energy on the moons, and why the gas giants rather than, I don't know, Pluto or something else, the moon of Pluto, why not?
Or indeed our moon. I mean, if I look at like the moon that we know the best, the one in the sky, it, I don't know, kind of feels like just a big chunk of rock. I don't have a sense that we're all looking at the moon and going, well, there's going to be life up there, definitely, no question. So why not our moon, and why moons around Jupiter, Saturn?
So there's two things. One of them is the planets are really, really big there. So the gravity is enormous, which helps. And the second is there are quite a few moons. So around each planet. And so what tend to happen is that the moon start orbiting the planet in a resonance pattern. So for example, if I take a gas giant such as Jupiter, the moon that is the closest to it will orbit faster around it. So Io will have time to orbit Jupiter twice, while Europa has time to orbit it once. And that means that quite regularly Europa will get a pull from Io towards Jupiter.
Okay, that makes sense.
And that means that the orbit of Europa becomes slightly elliptic. And elliptic is really interesting because it means that sometimes it's close to Jupiter and sometimes it's far from Jupiter, just a little bit. And what's really interesting with that is it becomes kind of, Europa becomes Jupiter's stress ball, if you will, because Jupiter will pull on the closest surface of Europa and also on the furthest. So it sets up a difference of gravitational pull on the two extreme surfaces of Europa. And that difference changes because the orbit is elliptical. So Jupiter just squeezes and relaxes Europa again and again and again, every orbit. And in so doing, it gives it energy.
Right. So there is a mechanism there for Europa, which might otherwise, I mean, it's fairly small. I mean, how big is it in comparison to, say, our moon?
I have no idea.
No idea. But I mean, I'm not imagining this is an enormous thing.
Small, it's much smaller,
It would have cooled,
yeah,
right? But it's not, because it's getting this transfer of energy through this gravitational mechanism from Jupiter and its interaction with, what was the other, from Io, right. So that gives it a source of energy. And that's one of the three. You've got the water, you've got the carbon, which are just there. And then you've got energy, which is good.
Absolutely.
So what does that show up as on Europa?
As far as we believe, there are now massive oceans, underground oceans on Europa, or under Europa's surface. So we have everything. We have a lot of water. We have carbon, we have energy, and now the question is, are there fish?
Yeah.
Because Europa has so much water, it's just like an ice ball. So if it didn't have this, it would just be like a icy sphere, I guess. But because of this tidal sort of stress back and forth, it's got warmth in the center of the moon, and so it's still an icy crust.
Oh,
basically.
yeah, because it's minus 200 and something degrees there.
I mean, it's a long way from the sun, right? And Jupiter is not particularly warm either.
And I mean, it wouldn't have an atmosphere to sort of trap warmth in, I guess.
Well, yeah.
We don't know.
Europa doesn't really have an atmosphere. There's some stuff that stays a bit, but it's not a lot.
Right. Yeah. Right. But the interesting stuff is happening underneath the crust. And again, idiot question. Like, we know this? We've been there, have we?
That's a good question. So for Europa, the answer is no.
Not quite,
We
no.
kind of... We think there is water because the Hubble telescope has caught sight of things that look like geysers
Okay.
a couple times from the same place.
So like jets coming off from the surface.
But this is very patchy evidence. The Hubble telescope is very, very far away from Europa, and it's not many pictures. Then, of course, there's a physical understanding that I gave you, and that is our maybe main source of confidence for it.
But it's a bit circumstantial. It's kind of, we know there will be water in this vicinity. And we know that a planet like this will be getting energy.
Yeah.
So it'll have energy. And so we're inferring it's probably like this. Does that, is that as close as we've got? It's probably like this.
We've been a little bit further than that as well. We have sent satellites that have done flybys of Europas, and you can measure the gravity of a planet very precisely. And using those very precise measurements, you can try and interpret how differentiated the inside of a moon or a planet is. And it looks like that should be water-ish type. But we're not convinced, and that's why we are sending Europa Clipper there to just make sure. And so what Europa Clipper will do is actually just scan the surface and look at whether or not it goes up and down as Europa is orbiting Jupiter.
Right, whether it gets squished like that stress ball as it's going around. So Europa Clipper, that's like, sorry, forgive me, we might even have talked about this, I don't remember. Is that already on its way?
It's on the way.
It's on the way. Okay, so when are we expecting it to get there?
I think 2030, something like that.
Oh, it's not
Maybe
far
a bit
away.
before.
Because these things can be, we'll find out in 2180, you know. It's a very long way. But 2030, that's around the corner.
Yeah.
I mean, it's
That's
Christmas
just after
now already.
Christmas, right? yeah.
And so that's the question. If we see the surface move a lot, then it's probably liquid. If it doesn't move a lot, maybe it's just still frozen.
Sure. But this, I mean, it's in the name, right? This is a spacecraft which is designed to go there and have a really good look.
Yep.
Presumably for this reason, that it's got to be an interesting place. So let's spend a lot of money and a bunch of time and a few people's careers getting there and taking a good hard look.
Exactly.
And is that specifically because it might have life? Like, is this we're looking for life-led mission?
That's a good question. I think that's a lot of where the funding may come from, because it's a really good prospect. But there's also really interesting physics to talk about that.
All right. Well, that's something to look forward to in a couple of years' time. Okay. So there's Europa.
Yeah, and it's kind of impossible to talk about Europa without talking about Enceladus, right?
Yes.
Because they're so similar. So
Enceladus, is much, much smaller, but the ideas behind it are the same. So this one is around Saturn, and all of the explanations are...
So Europa around Jupiter, Enceladus around Saturn. So even further out, further away from the sun, even colder, except same idea, getting energy from Saturn itself.
Absolutely.
Okay.
But it's much smaller. Now, the thing that is absolutely amazing about Enceladus, and I still can't believe we've done it, is, there was a satellite orbiting Saturn that went doing a lot of flyby around Enceladus, took pictures of the things and saw geysers. And this time, because it was very close to the moon.
So we've actually seen this.
These
this is
ones,
not Hubble going, I think I can just make out. This is, there. I'm pointing to it right now.
Absolutely there. We also have infrared pictures that show that a part of the moon is much warmer than the rest. So we know there is energy. It's actually quite interesting that the energy is not distributed uniformly in the moon. It seems to be the south. It's got these things called the tiger stripes. And the really crazy thing is, so we didn't know these geysers were there, took pictures of it, and then people decided, well, let's fly through them, because why not? We're there.
Yeah.
So we have actually flown a satellite through the geysers.
That's mad.
Off the moon of Saturn.
You can imagine that going around mission controls. Can we do that? Is this allowed?
Yeah.
What are they going to do? Stop us? That's fantastic. Can I just back up a little bit? Which mission are we talking? When was this?
Cassini. When did it go out? 2016?
2005 it was when Huygens landed, right?
Yeah.
So it must have left in the 90s.
And when was the grand finale? That was not too long ago, was it?
I would guess late 2010s-ish.
What was the grandfather? That sounds ominous. That sounds very final. What did they do?
Well, so one of the big things that we mentioned before is the muddy boot. We don't want to do that.
Right. Yes. We don't want to add our own nastiness to anything that might be up there.
Exactly. So we try and dispose of our satellites in as clean a way as we can, which is not actually that clean. So what we've done with Cassini was just let it go down into Saturn's atmosphere.
Into Saturn?
Yeah.
Just plunging down.
Exactly. And just get burned up by just the sheer velocity of going through that.
That must have looked awesome. Do we have any pictures of that?
I believe we do, yeah.
Yeah, I think so, yeah.
Wow.
And really exciting data as well, because now we know a lot more about the atmosphere of Saturn because we went there.
That's wild. So before that, then, it was flying through geysers on
Enceladus.
On Enceladus. Yeah, thank you. My brain just went blank. And then plunging down into Saturn to end its life.
Exactly.
So this is exciting because we know they're there. We've sampled them.
Absolutely.
Like we know what's in it.
Well,
in the material.
With the precision we had at the time, because the mission was not made to go through the geysers of Enceladus.
Right, of course.
So
they didn't design it that way.
There were the tools that there were.
Yeah. What can we stick out through a hatch to grab stuff?
And what they found is a lot of fairly complex carbon molecules. Maybe they are more complex than the ones we've recorded. The thing is, we don't know because we didn't have the tools to sample that. But the ones that have been found were fairly complex. So there's complex carbon molecules, water, energy, because, well, the water needs to jump, of course. So you need energy for that.
Yeah.
So Enceladus is very exciting because all of the ingredients are there and we are 100% sure of it. Europa is a better prospect because it's bigger than Enceladus. So we think, from thinking about it, that it should be the same but better. And that's why we're so excited about Europa.
Why does, in this case, size make a difference? Is it just simply sheer volume of stuff within which the magic of life could happen, or is there some other reason?
There's that, but also the stress ball mechanism works better if you have a big moon.
Okay. You were talking before about how Enceladus, it's surprising that the energy seemed to be concentrated in different places. Do we think that's because it's so small that it's, a very small stress ball might act in strange ways? And that kind of weirdness of energy, it could be interesting for the development of life.
Yeah. At least what I'm not surprised by is the fact that they seem to have less liquid water on Enceladus than we imagine there is on Europa. And that's because it's smaller, so the stress ball mechanism works less well. Now, why is it concentrated somewhere? I couldn't tell you.
I'm sure our students writing essays about all the wonderful life that we're going to find on Enceladus will tell us that it's the geothermal vents that are popping up and all these things. But there's no physical evidence for anything like that at this point.
But why not speculate?
Well,
eh?
Yeah.
Why not?
I mean, it's not wrong to speculate. You just got to be clear that you're speculating. So, well, I guess then talking about Saturn and talking about Cassini, it's impossible. I already said the word not to talk about Huygens and the probe. The fact that we've landed on a moon.
Okay, yeah. So back up. Again, I know nothing. So talk to me like I know nothing. What happened? When? Who and how?
Well, Clément maybe probably knows more than I do.
You can do it if you want, Emily.
I'll start you off. Yeah. How about this? So Cassini mission came with a probe to land deliberately into another one of Saturn's moon called Titan, which is a very cloudy planet that we knew nothing about. So we just thought, let's just send something to the surface to find out what's there. And then, and that's exactly what we did.
And it did. And what happened?
So Titan, I mean, the fact that it's a cloudy moon, it's important to say that it's the only cloudy moon
so
in the solar system.
Cloudy as in atmosphere, as in literal clouds.
Absolutely. And what's absolutely incredible about Titan and why it's so exciting is that it's the only other place in the solar system, including planets, that has, I was about to say hydrological. We'll say hydrological for now, cycle. So there's rain, there are lakes, there are glaciers.
We know this because we've been there.
we know this because we've been there. We know this because we have really good measurements from afar, and we see these things change over time. Wow. We have good spectroscopy as well, so we know how thick the atmosphere is, and we know all of this. And I was saying, so hydrological is not the right term because, again, this is very, very cold. So you don't have liquid water there. You have liquid methane.
Okay, right. So it's methodological.
Methanological. Something.
Sure.
Yeah.
Let's go with hydrological. Do we just have to remember brackets, methane, end brackets? Right. So it's raining methane.
It's raining methane.
Glaciers of methane. Mm-hmm. That's wild.
Glaciers of water as well.
Okay.
A lot of water, again, on Titan is just frozen.
Right. So it's not raining water. It's not. There aren't rivers of water, but there are rivers just of methane and other stuff. But that's wild.
Absolutely. So landing there was kind of the right thing to do. I mean, why not? There's lakes and everything. I mean, actually, there was a mission that wanted to land on one of the lakes, like a boat, but it's been cancelled.
We wanted to go skiing.
Unfortunately. Now we have Dragonfly, so we'll have a helicopter there, well, a drone. And that's going to be very exciting as well.
Is this like the one we sent to Mars? That same idea? Wasn't there?
Same idea.
Same idea. The little helicopter buddy that went up with which of the rovers?
It was Ingenuity, wasn't it? The little helicopter.
So same idea. So we're going to do that again.
Yes, and it's going to work better because Mars has a very, very weak atmosphere, very thin.
Hard to fly a helicopter or anything in a very thin atmosphere.
Exactly. Titan has not a very thick atmosphere, so you can fly something that's much heavier, and that means you can bring a lot more scientific instruments. So it's going to be a very, very exciting mission.
So we're going back. Like when is this happening? And which mission are we talking about?
I think it's been delayed recently. It's costing a lot of money.
That'd be right.
And it takes a bit of time to go to Saturn, so I'm not too sure about the date. Might be a while.
All right, so let's not hold our breath. Let's just hang on to the whole 2030 time frame for the other one. Can I just go back a little bit to landing there? What was the name of the probe?
Huygens.
What about the whole dirty bottom of the boot thing? Like, weren't we concerned that we were just about to populate this really interesting place with stuff that we sent along? Or was it like, did we spray it really carefully with disinfectant before we left?
I'm sure that's been done, yeah. People have been worried about this for a long time.
Yeah. But we figured this one was worth doing.
Yeah. And it landed, and it essentially landed at the bottom of a dried up river, where we could see rocks that had been eroded by flows. So a very terrestrial-like place.
Wow. And so, I know this sounds really, really stupid. I can't believe I don't actually know this, because it kind of feels like we get inundated by all this stuff about Mars and the rovers on Mars and the pictures from Mars. This is amazing. How do I not know that we landed in the bottom of a dried up river on a moon going around Saturn? So that's not a question for you. That's more of a rhetorical question. The question is, so we've seen pictures of this?
Yeah.
Yeah.
There's
a wonderful video
of
the descent of the probe, and you can see the landscape of...
When was this?
2005, I think. Right?
Was I asleep? Did I pass out? Oh, no, I know what it was. 2005. That was when my first child was born. I just disappeared for 20 years now.
To be fair, I mean, it was exciting if you're into, obviously, solar system exploration and things like that. But I think even then, at the time, it wasn't sort of like we're going to be finding green alien life really here, because although we're talking about things that sound tantalizingly Earth-like, let's roll back to the number one headline. Titan is freezing, below freezing.
Did we mention this is methane?
It is really cold. Yeah, it is liquid methane. I mean, we don't know of any, I think, particular species that have evolved in the absence of, water and things like that. Although there might be methogenic bacteria and blah, blah, blah. I mean, does methane-based life exist? Oof.
It's unlikely. Water, I mean, it's not for no reason that we like water. Water is an extremely good solvent. So chemistry happens really fast.
Right, I see what you mean. Yeah.
And actually, the speed is very important. You just talked about Titan being freezing. We put stuff in a freezer so that chemistry, biology stops.
Yes.
Right?
Yes.
And a freezer
you store your food longer. It doesn't spoil as quick.
Exactly.
In a freezer.
And that's minus 18 degrees, right?
Yeah.
Titan, we're talking about minus 200 and, I don't know, around minus 200 degrees.
That's a really good deep freeze. That's nothing that we know of is happening like that. Yeah.
So it's fun to imagine maybe very, very slow life, kind of a Lord of the Ring ends are so slow that you don't recognize it as life. But
Ponderous trees.
then you have to ask yourself, okay, but does that have time to evolve in only 4 billion years?
Yeah. Okay, so
we're
maybe
not
that mission,
sure.
maybe that mission wasn't strictly, I think we're about to land right next to life. But I don't know, this is still rhetorical, but I still find it amazing that I was not aware that we'd actually landed and taken photographs of the place. I'm going to have to go and look that up now. I'll be Googling that tonight.
And I think there's one more thing to say about Titan that makes it really, really exciting is it's also Saturn's stress ball. Therefore, we think, although the evidence, again, is a bit patchy that there should be underground oceans of liquid water this time.
Okay, so the surface not so hospitable, but for the same reasons as the others that we've talked about. Yeah, but you dig under the surface, you scratch under the surface, and there could be all sorts of stuff in there.
And that becomes really exciting because we have all the methane and carbon and everything at the surface, and the water would be under. So if you can imagine exchanges, and maybe it's impossible, we don't know, but if you can imagine exchanges between the two, that could be a really exciting place for life to form.
Awesome.
Yeah, it's almost like Earth turned inside out in a way, isn't it?
Yeah, that's a good point.
Well, it's not Earth. Earth isn't cold, but it's got that. The inversion.
All the oceans on the inside.
Yeah. And all the carbon on the outside.
All right, where are we going from here then? Are there any other places we want to explore?
I think those are our main three. I think we're probably deluding ourselves if we're going to start talking about, life in the atmosphere of Jupiter or Venus or
what about the asteroid belts? Like I've watched Star Wars, Empire Strikes Back, right? And they go through the asteroid belt and there's the big lizard thing living in one of the rocks. I've seen that. That's bloody documentary, that is.
Yeah.
No, we're not. Well, no one's looking at the asteroid belt.
Let's wind back from that one.
I mean, I have to admit, every time I watched that, even from the first time I watched it as a kid, there was a part of my brain that was going, yeah, but how would that even work? You've got an enormous sock puppet lizard thing living in an asteroid belt. Like, how often is it going to get a feed? Just waiting for something to come past. Anyway, look, listeners, don't write in with your pet theories. Or actually do. That could be really entertaining. But let's move on.
Yeah.
Not the asteroid belt. No. But are there any other places in our backyard where we might look?
Well, I was going to actually get Clément to put his money back on the table now with our last three, because we got Mars 100%. Yeah. What about these three moons?
Well, that's a good point. Yeah.
Well, I really like to believe in a complex-ish life inside Europa, but that's something I like to do with my brain. Does it make it realistic? Fish on Europa.
So when you're talking complex-ish, you're going beyond the simplest, single-celled...
Beyond microbes.
Right, and into multicellular, all the way up to fish.
That's what I want to see.
Things with teeth.
Are they tasty fish?
Oh, I don't know.
Don't ask that question, because you know that's going to be the first thing that we do.
I bet they will
it's going to
be
the
tasty.
Second thing we do. Yeah. The first thing we do is get there and find them. The second thing is we're going to bloody exploit them.
Yeah.
Bring them back and sell them for a fortune to Elon Musk and his mates.
No, they're either going to be so tasty that we'll eat them all, or they contain some rare mineral that we need for the next generation of technology, and we'll mine them.
So depressing. Yeah. But seriously, fish.
Well, I've read at least one scientific article that looked at the available carbon, energy, and all of this on Europa and said, yeah, there is enough to have a significant biomass. And you could therefore imagine things the size of fish. They could potentially survive. There's enough stuff there for it to survive.
Okay, enough stuff. Here's a question. Has there been enough time? Because we know that here on Earth we've been evolving for how many billion years? I mean, as you said earlier, life kind of happened as quick as it could, as far as we can see on Earth. But that's several billion years, right? And sure, we've had complex life for quite a long time now. It's not like it happened just yesterday. But even so, it takes time, a long time. How long have the moons been there going around these big planets? Like, do we know? Do we know how long that's been?
That's a good question. I'm sure some people know better than I do.
I think it's nearly as long as the planets themselves. I think most of these larger moons are believed to have basically formed in situ rather than have been captured objects.
Okay, so at least potentially we have the material, we have the energy, and we hope probably the time. So maybe sounds good. You put another 50 down, saying Mars 100%, and it'll look. Let's say at least one of the moons. Yeah.
Oh yes,
100%. Yeah.
And the thing about the moon is they're all very similar. We talk a lot about Enceladus, Europa, Titan. All of the moons have water. All of the moons are little stress balls. So if we find life on one of them, it's just likely that it would be there in some form on the others. Maybe not as evolved because there's not as much energy, not as much water, not as much carbon available. But that's why we're focusing on a few of them, because they are very good prospects. But all of them are absolutely exciting.
Yeah, I mean, that really does bring us back to that notion of, let's assume that here on Earth it's an N of 1. As we said before, it could be many experiments that have happened on Earth, but we don't know. Let's call it N of 1. One planet, one place in the universe that we know of that has life. If we get another one nearby, then that really raises the stats on, well, then we just got to keep looking, because if we found it there, surely, it's going to be in the other places as well. And that's the big question mark around all of this discussion is, we don't know whether just having all the right bits is enough.
Exactly.
Because we can't pin down, but how did it happen here? We just don't know. And so we don't know how lucky or inevitable that was, right? Yeah. God, do we have a solar system full of life and, fish swimming in underground oceans on moons around
tasty.
Saturn?
I'm just thinking of recipes right now.
It is late in the day. You're getting hungry.
I wonder if there's like local seaweed that is there as well that would go, because often you find that fish would go with something that's from. I'm getting off track here.
You're now talking about
the fish
sushi.
food.
Yeah,
sushi
recipes.
Saturn's
Like
moons.
often you find ingredients that if the other ingredients in that local environment tend to pair quite nicely with them. Like I'm thinking, like like samphire goes really well with lots of like soft shelled meats.
Do you know, I really didn't think this is where this discussion was going to go, but here we are.
Clearly a bit too hungry recording this. But anyway, so if we're going to find out some more information about this, we obviously need to send more stuff, right? And we mentioned one probe that's already on the way, which is Europa Clipper. There are other ones. I think I listed a couple off the top of my head. We already talked about Dragonfly.
And which one was Dragonfly? Sorry. Oh, that's the helicopter.
Helicopter one, yeah. There's been several proposals, I think, for sample return missions from Mars. Maybe they're more likely because people want to fund personed missions to Mars.
Yeah. But we haven't, we've never done sample return, right?
No.
From Mars.
No, we've started hiding little caches, little treasure,
those
treasure
ready
troves.
to be picked up. Yeah.
Doggy poo bags, sort of hiding them under rocks over here, and come and pick this one up.
Yeah. But no, we haven't sort of figured out how to get them back yet because, and this is something I know Clément's an expert, and it turns out it's harder to get back than it is to get there. In terms of the travel to Mars.
Harder to get back from Mars to Earth than it is Mars.
Well,
Earth
I
to
mean,
Mars.
what's interesting is that it's both harder and easier. It's easier because the gravity of Mars is less, so it's easier to fly off from there.
Right, you don't have to try as hard to get off the surface. Yeah.
But you have to find a way to have a rocket there full of fuel first. And that is the trick question.
Yeah, taking your return rocket with you to Mars, that's a big load. That's a lot.
Either that
That's
or
a
you
lot.
make it there, which is kind of the question.
Yeah.
And for the fuel, I think the idea is we'll make it there, but how?
Yeah. And then we've got to dump a whole lot of energy just to get back to Earth, because if you're going inwards in the solar system, you have to slow down to catch up.
I was about to say, you can just
it's
fall,
quite hard.
can't you? Can't you just fall towards the sun? Oh, I think I've just seen the problem with that.
Yeah.
You've got to slow. It's not the fall; it's the sudden stop at the end. You've got to slow down to get back to Earth, and that's a lot.
Yep.
Yeah.
It's why it's so much easier to send things to Mars than it is to take them to Venus or Mercury, right?
Right.
Even better than that, I think, is, it's just the continuation of the same argument. The hardest place to get to in the entire universe is the sun.
Right. I mean, well, getting to it is not
Falling
necessarily the hard
on it.
part.
Missing it.
Staying there, having a good look, presumably the hard part. Like you can fling yourself past it, no worries.
Yeah, but in terms of energy, falling into it is very, very difficult.
Yeah, yeah. No, I hadn't really thought of it that way. Yeah, it's a fair point. Fair point.
Yeah. So anyway, coming back to all of these missions, are you excited about any of the above or any other ones particularly that you're sort of keeping a half eye on?
Well, okay, I'll start with a mission that's actually happening and actually on the way, and that's JUICE. So JUICE was some of the magnetometers, for example, of JUICE that measure the magnetic field of everything you want, were being built in my lab during my PhD. So I have some sort of emotional attachment
Where
to
was
them.
this? Where was this?
In Paris, the Laboratoire de Physique des Plasmas. And I'm a plasma physicist, and what JUICE is going to do is very, very exciting. So JUICE is the Jupiter Icy Moon Explorer.
It's a good name. We've talked about names for things on this podcast many times in the past, and that's a good one.
It is.
That's a good one. They worked hard on that.
And one of the things that it will do is it will orbit Ganymede, which is one of the moons of Jupiter, and that's the first time that a probe orbits a moon. And
As
Ganymede,
opposed to just flying past.
Exactly.
Yeah.
Doing a flyby. And Ganymede is really exciting for a plasma physicist because Ganymede is the only moon that we know of that has a magnetosphere, because it's the only moon that has an intrinsic magnetic field that we know of. And I told you I study the interaction of the solar wind with planets. So I study the interaction of magnetospheres with another plasma, which turns out to be the solar wind. But Ganymede is inside Jupiter's magnetosphere. So it's a magnetosphere within a magnetosphere. And it's oriented in a way that the magnetic field of Ganymede is directly opposite to the magnetic field of Jupiter.
Oh, that's got to be fun. What does that do?
Something called magnetic reconnection that has been fascinating me for as long as I've known about plasma physics.
Because, I mean, magnets are hard. Magnetic fields are weird and they do strange stuff. So that's got to be quite bizarre.
Constant aurora borealis.
Wow.
And Australia's
That's cool.
on Ganymede.
Let's go and orbit that for a bit.
Absolutely. So that I'm excited about, and that's a mission that is on the way. So I'm very excited about it. Now, for the missions that are not yet planned for real, there are a few that I'm excited about. So one of them, the point of Europa Clipper. So it sounds boring to some extent. You're like, oh, you're just going to orbit it. Why not just go dig the ice? Well, because we're not sure 100% that there's an ocean. So we're not going to make a drill to go to the ocean if we're not sure it's there. So Europa Clipper is going to go there to figure out if there's an ocean and to figure out where to land. And so the next mission after that, I'm very excited.
Hopefully the answer is isn't that you've got to dig through 5 kilometers of ice, because
it's going to be worse than that. It's going to be 100 kilometers of ice.
Yeah. Well, I mean, maybe hopefully it's not 200, but hopefully it's not so much that it becomes technologically impossible, I guess.
But the point is you want to know.
Yeah,
absolutely.
This is the recce mission. We're going to land there and we're going to have a drill which is going to get through 150 kilometers of ice. Somehow that's on you guys. We've done our job. That makes sense.
And then there used to be a mission that used to be planned, and I think it's not in the cards anymore, but that's so sad, is sending Zeppelins on Venus.
Wait, hang on, back up. Zeppelin, the big airship things to Venus.
Yep, with people inside.
Were people on drugs when they were doing this? That's the most insane thing I've heard in my life.
It's been a serious proposal.
That's fantastic.
I think it's gone, but inhabited Zeppelins on Venus.
We need to bring that
Wow,
back.
inhabited, yeah.
Come
Inhabited,
on.
yes.
So you go for a little holiday in your little Zeppelin and look at the penguins that are fighting over the fish that they've collected from
That's fantastic
Europa.
idea.
And the idea is, quite simple in a way, is because the top of the atmosphere of Venus is the same pressure and same temperature as Earth, the same gravity. So everything is very Earth-like. at the top of the atmosphere of Venus.
To be clear, the surface of Venus is a hellscape. Let's not go there.
Yeah, well, we've been there once and it was awful.
Yeah.
And we've never been back.
And we haven't sent people there.
No.
Nope.
So, I mean, I guess if you are going to go all that way and have a Zeppelin, you want to make sure that that's you know what you're getting in for. It's like, and when do we land? No, we're not landing. Oh, I didn't read the fine print on that one.
Well, that's very cool, though. I like that. Okay. I mean, let's away from the I don't even know how to describe that. Is it fiction?
We've been speculating, there's blimps on Venus.
Yeah,
but
yeah.
Anyway, there's another title, Blimps on Venus.
There's more science to be done in solar system science than just looking for life.
Sure.
And, Clément's a wonderful example, right? Interested in the plasma physics of the solar system.
Yeah, those magnetic fields, you're not looking for life in those. That's for its
Nope.
own thing. And that's cool enough. Let's be absolutely clear. As physicists, magnetic fields are cool. And let's go and explore them, because that's wild, right?
Earth has a magnetic field.
Sure.
We don't understand the implication of what magnetic fields might have for life in general. So
Sure.
it's not out of the question
Sure.
that you're off to
absolutely.
find.
That's the big
impacts.
question that I have at the moment, which is, are magnetic fields actually protecting atmospheres or not? Is it complicated? And the temporary answer I can give is yes, it is complicated.
Because it's magnets, and they are. Like everywhere we found significant magnetic fields in the universe, it's been, that's hard.
Yeah.
Like the equations of that are really, really ugly. But yeah.
There's a whole field called magnetohydrodynamics that I just run away from.
With a lot of
because
people with migraines.
It's too much maths for me. It gets too hard. But there are very clever plasma physicists, especially, who do this field of study that I am in awe of.
It's fun physics, right? It gives you all sorts of fun stuff.
Yeah, I'm not sure I passed that exam.
You should try.
Anyway, but coming back to the solar system, so we've talked quite a lot about places that seem to have subsurface oceans. It just seems to be a thing. You said water is everywhere, but it seems to be mostly under the surface. I think there's various reasons for that. But are we learning now that this is just the thing for our solar system? You find water underneath things?
I think so, yeah. One of the most surprising results we got in the past 10 years was that Pluto seems to have an underground ocean.
Pluto?
And that is...
Pluto. The Pluto.
Yeah.
All the way
The one
out
that
there.
was a planet.
The one that was a planet, no longer a planet. Really small ex-planet, Pluto.
Not even the moon of a gas giant, so what is going on?
What's going on there? That doesn't seem... right.
A lot of antifreeze chemicals, a lot of radioactivity.
Yeah.
Maybe interaction with its big moon, Charon. Charon was a planet for about a week. Because, it doesn't actually orbit Pluto. Like everything, they orbit the center of gravity of the system, right? But the center of gravity of the Pluto-Charon system is outside of Pluto.
Yeah, because Charon is like almost the same size as Pluto, or quite, at least very big.
Yeah, very
big. Yeah, and so the center of gravity is, let's call it somewhere towards halfway between them, outside of both of them. So for a little while, astronomers said, I'll call them both planets. And then when someone went, no, we can't.
Something like that.
Yeah.
Reel that back in. Neither of them get to be planets. Pluto's going, hey, wait. I was always, until you came along.
Well, someone think of the preschoolers who can only count to 10. We can't have any more planets than 10.
Like, that's it. Neither of you get to be planets. Oh, Dad. It's not fair.
Anyway.
Anyway, yeah.
Sorry for the tangent. Yeah,
No,
so
it's great.
underground oceans.
Yeah, that's
that
a thing.
just seems to be a thing. And it's very exciting in the case of Pluto, because Pluto might well be the most representative body of the solar system that we know, because it's part of the Kuiper belt, where there's just hundreds of things that are just like it.
Right, yes. Because, of course, we always spend our time with the big planets that we know. And then we kind of get to Pluto and go, you don't get to be a planet anymore because you're not quite. But, of course, beyond that, there's still loads of stuff which still counts as our backyard, our solar system. So, there's potentially loads of places.
Loads of places.
Yeah.
Now, it might this time be really too cold.
You're prepared to draw the line out there.
Well, I don't know. I'm not the one to draw the line. It's interesting to look. The probability that we find something is significantly lower, and it's also way further away. So going there to find something takes a lot of time, a lot of money.
Go for the easier things first.
But if we find something there, that's it, we're done.
Yeah, life is everywhere. Then.
Yeah. We can draw a line under this. It's everywhere. The universe is teeming with it. Yeah. But what I hear you saying, because like out there where you're talking, like there's loads of stuff, right? And particularly lots of little chunks of things.
Absolutely.
Yeah. So what I hear you saying is 100% absolutely big Empire Strikes Back lizard sock things in rocks eating spaceships as they go past. I'm like, that's what I'm taking away from this.
Yeah.
No?
Not what I say.
But what I like about this kind of concept of the more we learn about our solar system, it also tells us, of course, about the exoplanet through systems, because we have the privilege, I guess, of exploring our solar system in this exquisite detail. I know you say that even the Hubble Space Telescope pictures of Europa where you squint and you think you see something, that's already orders of magnitude more than what we know about any exoplanet, right? But if our, again, sample of one of our own solar system is telling us, everyone's got water, mostly underground, but hey, everyone's got water, we can determine that lots of places have energy because of various gravitational interactions or radiative decay or something like that. And carbon, I mean, that just seems to be everywhere as well. I mean, that's quite exciting when you think about then exoplanetary systems that have almost every permutation of our solar system that you can imagine. Does that mean there's the same three ingredients everywhere?
Certainly does, yes. I mean, the problem with the extrapolation of what's happening with our moons to exoplanetary systems is that, there's a good reason why we're looking for planets in the Goldilocks zones when we are looking at other stellar systems. We want a place that has water on the surface because then we have life on the surface, maybe. And if we have life on the surface and an atmosphere, we can measure the atmosphere and then have signs of that life, which is something that we could potentially do with light for things that are very, very far away. Now, if there's life on the on a moon, under the surface of a moon in an underground ocean, in a other stellar system, how the hell do we know about this?
Yeah.
The answer is
So it's the difference between, like, if we do get to the point where it's like, okay, life's basically everywhere. We know we found it, obviously on Earth, and we found it on this moon around Saturn. Therefore, ... it's probably everywhere, right? But in order to actually be able to point to something across the other side of the galaxy and say, definitely there, you're saying, it needs to be on the surface because it needs to be able to affect something that we can actually measure.
Absolutely.
Right? We're not going to be able to point to it and see it running around on the surface, but we'd be able to see its effects on the planet. And we're not going to see that if it's under 100 kilometers of ice. That's just not going to happen.
Nope.
Right. Okay. Fair point.
But it influences the philosophical question of life in the universe, I think, and perhaps.
Yeah.
So I'm going to ask the very hypothetical question. Well, I've got two actually. I've always got
finishing with some
horrible
hypotheticals.
questions.
Good.
Yeah.
Good.
So first of all, I like this idea. If you had unlimited funding, where would you send a life detection mission?
Yeah, you get to spend Elon Musk's money. So where are we going?
That's kind of a difficult question. I think we're already doing so well with the solar system. I feel like my imagination is kind of limited. And all the ideas that we have for the solar system are so good. We just need to actually make them happen, which is what I'm slightly worried about at the moment. Now, if you give me unlimited money and you tell me that Planet 9 exists, I want to go there. Ooh. Have you talked about Planet 9 on this podcast before?
Well, I think we've talked about it sort of parenthetically a few times.
There was a detection a few years ago that I think we did an episode on, but it was quite some time ago.
So just to be clear, Planet 9, tell me about Planet 9. What are we talking about?
Maybe there's a big planet that we haven't found yet on the outskirts of the solar system.
In our solar system, but like way out there.
Way out.
Because when I was a kid, we did have 9 planets, Pluto, and then as we just discussed, that's gone. But we're talking about not just there's another lump out there, but big.
Yes.
The point of Planet 9 is it's big. And why? Why would it have to be big?
Because the way people have figured out that it could be there potentially is by looking at the weird orbits of a lot of smaller things. And those weird orbits can be explained fairly well by the presence of a big planet.
Oh, I see. Okay. So there are some discrepancies in the orbits of what we do see, and the only way that they could be there is by something that we don't see, but that would have to be really big in order to affect things on that scale. Is that what we're talking about?
That was the initial explanation, in 2016, I believe. Now, it's quite controversial, and I think we'll have an answer soon for that one. Does it exist? Does it not? Anyway, if it exists, that's where I want to go.
Okay.
And I don't even care about life. I just want to see that thing.
That's fair. That's entirely fair. I think because it would be such an interesting change to how we think about our solar system, and
Absolutely.
really and push us beyond the Pluto. Even, astronomers think about the Kuiper belt maybe all the time, but not generally when you open up your children's books about the solar system.
No, it doesn't feature strongly.
So if you did have this other thing that was way out there, I think that would change our perspective quite dramatically.
Yep. And so if it's not there, so I get to keep my money for something else, I'm going to Alpha Centauri, I think.
Oh, nice.
Not that far. Could
Okay,
make
so
it.
you're taking the long game.
Yep.
You're taking very much the long game here. And is that simply just to get to a different star system, or is there something particularly about that one?
No, we've just never done it before, and it's close enough that it's not absurd to think that we could do it.
Yeah, and one of the stars in the system, Proxima Centauri, that does have a planet around it. So why not go and have a look at it?
Absolutely.
Weren't we talking about that last time, and didn't we conclude that it's not a very good
Well,
planet?
yeah.
It's not a great one.
I seem to remember.
It's not a great
I seem to
one.
remember when we were on the planet episode, and that was the first one that you went to, and then went, no, we're not going
Clément
there.
is spending someone else's money here, so we're not that bothered.
As long as he's going, you don't mind. That's totally
it's
fine.
fine.
That's totally fine.
And I know we were talking about life up to now, but it's a planet in another solar system. I mean, life or not, it's just fascinating.
Yeah, that's. I mean, surely at some point, that's going to be the thing we do. Probably a very long way in the future, but
It's the next natural step, isn't it? As humans.
just remember to wipe your boots.
Yeah, exactly.
Yeah. So that was your first hypothetical.
Yeah. So my last one, actually, you sort of answered it, so it maybe not be as surprising as you think. But yes or no, is there life in the universe that's not related to the life on Earth?
Yeah.
Well, there you go. Sorted.
End of podcast. There we are. So in this episode, we started by heading off to Mars and figuring out whether or not there's chance of life on Mars. And I'll put my cards on the table right now. At the beginning of this episode, I really thought that we were going to be hedging a lot around, we haven't found anything conclusive on Mars, and maybe we might. And Clément, you've just come out straight away, bang, down on the table. No, 100%, we're there. And that doesn't mean that we have found it or we will find it tomorrow. But I'm surprised, and pleasantly surprised, by just how certain you are that, surely it's there, right? That's cool. Glad you brought that through the door with you. I like it. I like a sense of optimism on the show. So thank you for bringing that through the door.
You're
Emily, did you think that we were going to go there today?
I didn't expect, again, quite a strong response, but I'm loving it. It's great.
It may take time, though, but
It may take time, but it's out there.
it's got to be there. Yeah.
All right. Well, listeners, if you have a differing opinion, if you want to take Clément up on his bet, 100%, look, send us your money and we'll put it in an envelope. And when it's found or not found conclusively, then we'll just distribute the funds accordingly minus our cut. I think that's how that works, isn't it, Emily?
Yeah.
Pretty sure. Sure.
We'll just go to the pub first to figure out the maths.
Exactly. Which
But I
might
think-
use up some of your money. Yeah.
The real next question is, if we find it, and we will, I'm sure we will, is it something that has a common ancestor with us
Yes.
or not? That's the
Is
real
it just an offshoot
interesting
of
question.
our own Earth life in some way, you mean?
Or not necessarily an offshoot. We could be an offshoot of it,
yeah,
or
that's true.
we could be the children of something else, the same parents somewhere else.
But what you're saying is, if there's a link, if we can see the same, I don't know, if it's based on the same kind of DNA type sequence or whatever, if we find common genes, for goodness sake, that would be wild.
And if we don't, that would be...
There would be wild as
Wild.
well. Yeah, both. I mean, it's a win-win, right?
Absolutely.
You've got to love that kind of win-win. Well, Emily, if people wanted to get in touch with their own theories about life in the universe, if any biologists wanted to get in touch to say, I would like to come on your podcast to talk about life because I know about it all, if people wanted to just send us their money, how do they get in touch with us here on the show?
Yes, well, we're fortunate enough to have wonderful electrons flowing through the Syzygy website, which is s3e3.fm. So you can go on there and you can click around all the wonderful bits and pieces. You can find season 1, as we mentioned before, which is all 120 episodes.
It's all on there.
Who else has a season of that?
Exactly.
That magnificence.
Exactly.
It's
we do
wonderful.
things on an astronomical scale in this podcast.
Indeed, we do. But there's also a little form that you can fill in. I want to talk to Chris and Emily. I want to say all the things I want to say, and I want to send you my life savings. No, don't do that.
Well, you could. Emily, don't put them off. If the listeners want to send us money, you're welcome.
But keep enough for the next week's groceries.
Yes. What Emily's saying is don't put yourself in trouble just for our sake. But if you do want to support the show, there is a way that you can actually send us cold hard cash. And that's by going to patreon.com and becoming a patron of the show. Patreon.com/syzygypod. And you can donate a couple of pounds, anywhere up to your entire life savings, minus next week's rent and groceries, to help us keep the electrons flowing through the website and to help us to do the things we do here on Syzygy, including, if you're in the York area, coming up next year. We've just been in conversations about this for a couple of live shows.
Yeah,
We're going to be recording a couple of live talks of mainly Emily with a little bit of me.
Well, yes.
We'll see how that goes. But my point is, your support helps us to do those things. So if you're able to, that's fantastic. But if you're not, otherwise, just tell people. Tell everyone you know that you think might be interested in the prospect of finding fish underneath the ice on a moon around Saturn.
Tasty fish. With nice accompaniments.
Oh, goodness. I really didn't think we were going to go there. Then tell them that Syzygy is the show for them. Listen, we are going to have to finish this. This is getting very, very silly. Emily, I will see you next week. Clément, it's been fabulous having you
Thank you so much.
on board. Thank you very much for joining us and for
me.
giving us a sense of universal life optimism. I love it. Emily, I will see you next week.
Yep, and I'm off to have some tea.
Sounds good. Bye, everybody.
Bye.
See you later.